So today, anytime they give you an equation, like they did in the two problems we looked at right here, this problem right here, right? They actually gave you the function. They gave you the function, right? So if they give you the function, you can use those steps there. You can use those steps that we did. We did 1, 2, 3, and 4 steps, right? Same thing with A, same thing for A and same thing for B, right? So the difference with the ones we're going to do today is that they don't give you a function. Like for C, take a look at letter C. What do they give you for C? A table, yeah. Is there any function they give you that they say f of x or g of x equals or something, anything like that? Like they did for B and A? No, it doesn't look like it, right? Doesn't look like it. Well, will our steps work? Will our steps work like we did for A and B? So read the steps again. Will they work for this guy? If they will, great, we'll just do it the same way. If not, we got to change it up. Okay. So take a look at the steps we've been using for A and B and figure out, will they work for letter C here? So can I do it the same way that I did? Will the steps work for AB for this one I have in front of me? See? Yep, it will work. Anybody else? I got a thumbs up. Yo, okay, let's do it then. Let's use those steps. We've already used those steps. Let's use them. Okay. So step 1. Step 1 said set f of x equal to a. Okay. So set f of x equal to a and then solve for x. Okay, so let's go back to letter C. So I need f of x. So I need to do this. For step 1, I need to set up f of x equal to a and then solve for x. What is that going to look like on this problem? What is that going to look like for this? You can look at A and B to see what we did there. So what is that going to look like here? What is that going to look like here? What's the issue? We don't have f of x, right? Up here, they told me f of x, right? Up here, they told me f of x, right? Do I know what a is for this guy here? 6, yeah, I know that, right? So I can get rid of that and put a 6 here, but right? But I'm missing f of x. There is no f of x, right? So that's the reason we can't use those steps that we did yesterday. Okay, so we're not going to be able to use those steps from yesterday when using a table. Okay, Well, luckily they gave us another one. They said, okay, so here are the steps to do that there, but here's the more formal definition here. So if I want to find the derivative of an inverse, use this instead. This will also work. Now I see an x here, but there is no just straight f of x. I don't have that, right? So let's try using this guy instead. Maybe this guy will be easier. Okay. So maybe this guy will be easier. So let's see here. Let's see if I can cut and paste. No, it won't let me. Okay. So let's go down here. So it says, let me write it over here. F of x so the derivative of the inverse equals 1 over, let me write it down. Let me write it down on the board so we don't forget it. Let's see. So one over f prime. Okay, there we go. Okay. Okay, so let's go back there. Write it down in the notes. So how do we use that guy? What do we do now? What do we do first if we're using this guy here? If we're going to use this guy here, what do we need to do first? So this basically, all this says is, it's a lot of notation, but this says, okay, this is the inverse, and I'm finding a derivative. That's what we're doing. I'm finding the derivative of the inverse, okay? And this is one way to do it. Well, that kind of looks familiar, like something we've done before. You guys have done things like this before. So when we wanted to do things like that, what did we do? Oops, they kind of look like those things there. Kind of look like those guys there. So I have one with the fraction, I have one with the fraction here. I have one g of f of x, g of h of x here. I have one here multiplying times each other. We've done those before. What was the first step, but what did I do first? Well, what did I do first back then? Give it an exponent? Where would I need the exponent? Oh, okay, I see what you're saying. This guy here. Yeah, see, that's the thing that I don't like about inverses. They use this notation here. It has nothing to do with the power. It's a notation, kind of like this here. I don't like that they use it here because sometimes it gets confused as an exponent and it's not an exponent, okay? Yeah, I don't know why they've been using that over and over and over again. I don't know why they do that. I hate when they do that, but it doesn't mean an exponent, but I like where you're thinking. That's one place to start, okay? So where else? Oh, so the whole thing like this. So the whole thing like this, right? So like that. We could do that. We could do that. But there's a lot of notations going on here. I don't really want to mess with more notations. It's okay. You can do that. There's nothing wrong with that. Absolutely nothing wrong with that. Making this, moving this to the top and putting a -1 instead. So putting a -1 like that. We could do that. Absolutely. What's the reason why we would do that? Why do we do that like on other things? What's the purpose of that? To do what? When we do that, when I move this guy to the top, give it a -1, move it to the top. Why do we do that when we do it back then? Yeah, but why do we do that? Bigger picture, why do we do that? Why do we do that? Why have we done that in the past? And then to do what? Find the derivative, right? We always do it to find the derivative so we can use one of our rules, right? Here's the nice thing. Derivative's already done. Yeah, clock's not moving. We still got a lot of time. See a lot of you guys looking at the clock. It's gonna be a while. Okay. We already found the derivative. That's the derivative right here. See this notation here? Right there. Derivative's done. So that's why we don't need to move it. If we were going to find the derivative of this guy, I would do that. I would absolutely do that. So derivative is done. Hard part's done. They did the hard part for you. So what do I do now? Okay, so what do I plug in? You're right. I'm going to plug in numbers. What do I plug in? Keep going. That's what I would start to do. Yeah, first thing to do is, what am I trying to find? Right? I'm trying to find this guy right here, right? I'm trying to find this guy here. That's what I'm trying to find, right? And it said g of x is equal to the inverse of that guy. And when I find the derivative, that means I'm finding the derivative of the inverse, right? And then when I find that, I got to plug in 6. So the first thing to do is plug in 6. So everywhere I see an x, I'm going to plug in 6. Okay. So far, I'm done. So the derivative's already been done for us. We don't have to find the derivative. The derivative is done, right? So we don't have to worry about chain rule here. We don't have to worry about doing chain rule down here because it's already been done. They've already done that for us. Okay. What we do have to worry about is solving this. So which part are we going to do first? Oops, that's supposed to be a 6. Let me change color so we can see it better. Okay. So in mathematics, when we want to simplify, what do we do first? In math, when we want to simplify anything, what's the first place we always start? In mathematics, when we want to simplify something, where do we always start? Parentheses. Yes, PEMDAS. Anytime you want to simplify anything in mathematics, you start with PEMDAS. Parentheses. We got a whole bunch of parentheses. So we start here on the inside here. That's where we're going to start here. So we need the inverse at 6. That's what we need, the inverse at 6. I have a 6 over here when x is 6. So is -5 the answer? No, why not? Yeah, it's not the inverse. But what do we know about inverses? Yeah, exactly, right? What was the very first thing on, it's the reason why I put it very first. What's the relationship between x's and y's with inverses in original equations? They're swapped, right? They're swapped. Okay. So what is this going to be? What is that going to be? Not 1/6. Well, let's see. What is this equal to? -5, right? So doesn't that mean that on that function, there was a point 6, -5, right? That's what that means, right? What about the inverse of f? What point is going to be on the inverse of f? -5, 6, right? So that means, okay. So what's the inverse at 6? No. This is asking for this guy here, right? It's saying this, except the opposite, right? So if on the original, f6, 5 is there, what's the inverse going to be? No. You guys are thinking reciprocal, not reciprocal, inverse. Let's go back up here. I think some of you know it, you're just afraid to say it or say it loud. 6 is going to be it. It's going to be 6. Okay, it's going to be 6 because f of 6 equals -5, right? So what's the inverse of that? Well, we got to swap it. And then what's the y? 6. So this whole guy right here is actually equal to 6. So it's going to be 1. Everything else stays. Because now I know the answer to this guy right here. Is 6. What's left? What's the last thing to do? Okay, so what is it going to be? -9. Done. Okay. So what is the, let me give you another one like that. I didn't put another one on like that, but let me find another one and I'm going to put it on the board or on the screen and let you guys work on that. Okay. There we go. Okay. Do that. Whoops. Okay. So we got to plug in -3. Okay. Oops. So everywhere I see an X, I'm going to plug in -3. Okay. So what is F? What is the inverse of at 3? -3. What's this part right here? What's the inverse at -3? -3. Surprised 20 people didn't say that. Okay. -3. Because the point at -3 is -3, -4, right? Flip it, and what's the new y? -3, right? -3. Okay. So, and then now this part here you've done a few times. F prime at -3. 1/2. 1/2. Okay. Yeah.
Can we technically just write the equation as 1/f plus the derivative of x?
1/f.
Because like f of -1, we just keep getting the same.
Oh, so simplify it even further? Yeah, you could. With tables, you could. Yeah, definitely. For sure. Yep. Okay. All right. So this one here, I want you to try this one on your own. It's letter D. Letter D. Try that one on your own. I'll give you about 3, 4, 5 minutes. So when you're done, look up here, see if you got my answer. This one was an equation, so I could go step 1, 2, 3, 4. I didn't have to use anything else. First step was I set it equal to a, which was -6. -6. Solve for x. This one was a cubic. So most of the time you're doing this, it's going to be a whole number answer. Most of the time you're doing this, you're going to get a whole number answer. Okay. You're not going to get a fraction or anything. If you do get a fraction, they will let you use your calculator. They'll say it's a calculator question. So, and most of the time these are not calculator questions. I don't think I've ever seen this be a calculator question. So it'll be a whole number answer. So you can do guess and check. If you can factor it, factor it. Sometimes you can factor them, sometimes you can't. So this one was just kind of a guess and check. I just plugged in 1 to see what I would get, and it worked. If that didn't work, I would go -1, +2. Usually it's going to be one of those guys. Okay. Because when you plug in 1, here and here, you get -3 + 3 = 0. Okay. And then find the derivative of f, which is right here. And then plug in the answer I got for number 1 into the derivative. I got -7. Flip it, you're done. Flip it, you are done. Okay, that was kind of like what we did yesterday. Okay. Most of the time you see these types of questions. Like I said, on your test that we have coming up here next week, early next week probably, you're only going to have one question. I guarantee you there's only going to be one of these questions, and it'll be a multiple choice question. Okay. When we start reviewing for the AP test in the spring, we're not going to hit this hard, because maybe out of all the 50 questions that you see, maybe one of them will be an inverse question. They don't put a lot of those on there. Okay. But it is important because it's part of the chapter. But I'm just saying, and practically speaking, they don't really use these a lot. You know, I don't think I've seen more than one on a test in all practice tests I've ever seen. Okay. These though, maybe a few more. Okay. Maybe a few more. Well, a lot of this stuff you should already know. Everything outside of the red box, you should already know in trig from last year. So when we're talking about inverse trig, what is the inverse? What do I mean by inverse trig? What's the inverse? Like these guys you did in math 3, trigonus. What do we mean by inverse trig? Before you start having a stroke, what does it mean by inverse trig? What do I mean by the inverse of cosine, or the inverse of sine, or the inverse of tangent, or what does that mean? What does that mean? I'm going to go talk to Mr. Feistel, and he's going to be very angry with you guys because I know he does a lot of trig stuff. My students, we don't cover it as much as Mr. Feistel does. Mr. Feistel, he does a lot of trig. So if you had Mr. Feistel last year, I'm going to tell him you guys didn't know what inverse trig was. He's going to be mad. So you guys had Feistel last year. You guys do a lot of trig. My class, we just do enough trig. We did this definitely, but he loves trig, so he does a lot more trig than I do. So especially you guys, if you guys had Mr. Feistel last year, I would expect you guys to know this. What does my students too, because we definitely covered this, but not as much as he did. What's inverse trig? We could, but even like easier than that. When did you see inverses? What was the question you were asking for inverses? So let me start with the regular one, with the regular trig. What is the question we're asking for this guy here? What is the question we're asking there? So what does this represent? So what does the part on the inside of the parentheses represent? The angle, right? And we're looking for the answer is going to be the y value, which is the ratio, right? Y over 1. Okay. So what do you think trig does, or what inverse trig does? Reverses the question. All it says is this. It says, okay, this guy in here is not going to be an angle. It's going to be a ratio. What's the angle? Isn't that what inverse means? You're just, this is X, this is Y, right? You're just flipping them, right? So you're changing the question. Here is the answer. What was the question? That's what inverse trig is. So if I say this, if I give you a question like this, let's see, let me get another page here. So if I give you a question like this, that's an inverse trig question. Wherever that happened on wherever angle that happened, it's going to be a couple angles, right? There will be a couple angles where you get square root of 2 over 2 for sine. All right, let's see. Let's look at it. Let's see. Square root of 2 could be at 135 degrees, 3 pi over 4, or it could be at 45 degrees, pi over 4. That would be my answer. Pi over 4 or 3 pi over 4, right? That's what inverse is. Inverse means you just change the question. Instead of what's the ratio at that angle? I give you the ratio. Here's the ratio. This is y over 1. What's the degrees? Okay, so that's all trig is. That's all when we talk about trig, inverse trig, that's what it is. Now, we just said there are two answers, right? For inverse trig, like we just said. This could be pi over 4, 45 degrees, or it could be 3 pi over 4, which is 135 degrees, right? Well, we just want one answer. So arc sine is another way of saying inverse sine. It's the same thing. Arc sine, inverse sine is the same thing. Okay, so don't worry about when it says arc or inverse tangent. If it has this right here, inverse sine or whatever, don't worry about that. It means the same thing. So inverse and arc are the same thing in trig. Why they have both, I don't know. We only want answers from negative pi over 2 to positive pi over 2. So the answer to this guy here would just be pi over 4. Okay. That's inverse trig. All of you guys have done it. Like I said, my students, we cover this, but we don't hit it hard. I just we go over it and I show it to you because it's important. But I know Mr. Feistel, he loves trig. If he could teach trig all day long, he would love it. So he goes into trig a lot. So I figured Mr. Feistel kids, students from last year will know that. Okay. Same thing. So I could do that for all of them. This is the ranges where my answers come from. So if I'm looking for cosine, a ratio for cosine, I only care about angles from 0 to pi. Tangent, same thing as sine. Arc cosine, arc secant, arc cotangent. Okay, that's last year. That's math 3 trig honor stuff. That's trig stuff. Okay, so what do we use them for? Well, derivatives. So look on your sheets. Look on your go to your sheets like this. Take this out. It says green sheets because in the past I've had green, but I didn't have green this year. I only had white, so they're white sheets. Okay, so what you're going to do is you're going to flip it over. flip it over to the back. And that's where I took these from. I took a snapshot of that. So you're looking at 19 through 24, 19 through 24. These are 19 through 24. Different order, but they're 19 through 24. 13 through 18 are regular sine, cosine, tangent, cotangent, cosecant, secant. 19 through 24 are the inverse of them. And what do you notice after 24? What do you notice after 24? What do you notice after 24 on here? It's blank, right? It's blank and we go to integration, right? That's what we do second semester. So after this is the last thing we're doing with finding derivatives. So this is the last derivatives that we have to find. Okay, that's it. Okay, that's where they come from. So the last two rows, that's where they come from. Okay, now you're gonna see, so students ask, do we have to memorize them? I wouldn't. What I would do is I would see patterns. Notice patterns. If you want to memorize them, you can. Some students do that. Some students are great with memorization. I was always good with patterns. Do you see any patterns in all of these here? Like, what's one of the patterns you see in all of the derivatives here? Okay. Yeah, every one of them has a u prime on top. Every one of them has a u prime on top. It's not memorization if it's all true, if it's true for all of them, right? So they all have the derivative on top. So that's the first thing. So if you see something like this on a test, first thing you're going to do is find the derivative of whatever's on the inside that goes on top. Some of them have positive, some of them have negative, right? Some of them have positive. Sine, tangent, and secant have positives on top, and then cosecant, cosine, and cotangent have negatives. But that's one thing. What's another pattern you see? You Rush? Some of them have, yeah, the top four have square roots. And what's inside of the square root? Isn't that kind of similar? Not the same, but it's similar, right? You see the top, the ones that do have square roots have 1 minus u squared, or the other way flipped, u squared minus 1. And then tangent and cotangent are the only ones that don't have a square root. It's just 1 over u squared. That's the hardest part of these. It's not using them. We're going to do a couple examples today. We'll do one example today, and then we'll do the rest tomorrow. The hardest part about these is just knowing which one to use. Okay. So yeah, so it's not, they're not, watch, when we use them, they're not hard. You're going to be like, that's it. But it's just kind of knowing the patterns. Yeah. So what does that mean? What does absolute value mean? So these guys have absolute values, right? What does that mean? Absolute value. Distance from zero. And what's true about the distance from zero? It's always, so if u is already positive, leave it. You don't have to have the square root, the absolute values out there. If it's already positive, you're good. If it's not, make it positive. That's all it's saying. Okay, good, yeah. Okay. All right, so, because again, 100% of the times you see these guys, 100% of the time you see these guys, they will be on multiple choice. So you're gonna have four different things to look at. One or two of them will not be, you'll like, nope, that's not gonna work. And then you focus on what does work. Okay, so we're gonna do some free response questions here, but like I said, when you see these on tests, they're gonna be multiple choice questions, okay? Okay, so this guy, let's do A. We got A here. So it's inverse cosine. We know that because it's the -1. It's the same thing as if you had this, sometimes you'll see the problem like this, arc cosine. That's the same problem, okay? Those are the same problems. They're not different, they're both the same, okay? So if you saw that problem there, it'd be totally the same. Okay, so what is u here? What is u for this problem here? X squared. Yep, x squared. Okay. So what was at the top again? U prime 2x. So we're looking for answers that have 2x at the top. There's going to be a few answers that don't. If this was multiple choice, there's going to be a few answers that have x squared at the top or something else at the top. So negative, that's my second question. Is it positive or is it negative? This one's going to be negative. What's the bottom part say? So what's the bottom part of R say? Square root 1 minus u squared. U squared. So what goes in there? X squared. So if I was to square x squared, what would it be? X to the fourth. Done. That's it. Okay. All right. Inverse sine here. Or arc sine. Okay, so what is u? Square root of 2x, right? And isn't the first thing we're going to do is find the derivative of that guy? So what should we do first? Yep. So is this okay? Exactly. I have a lot of people do this. Oh, okay, 2x to the 1/2 power. That's not going to work. Why does that not work? Why does that wrong answer? Why is this not equal to this? Why are these two guys not equal? Yeah, so if this guy was 2 square root x, then this would be okay, but it's not. It's the whole thing. So I have to have parentheses, okay? Like I said, I see that mistake a lot. If you don't do that, then everything else is going to be wrong because you started off on the wrong foot. So make sure you has nothing to do with inverse, but like I said, it's important. Okay, so first thing I'm going to have to do is find u to the first power, or u prime. So I use chain rule. So we got 1/2, 2x, subtract 1/2, subtract 1, I get negative 1/2. Okay, so it's going to be a fraction. So let me simplify it before I even start. I haven't even started the problem yet because I'm just taking care of the derivative of u. So it's going to be 2 times the square root of 2x. Because a 1/2 times that, right? Okay. So that's u prime. So let me go back here. The derivative is going to be that answer up here, 1/2. And then what was at the bottom? Yeah. Yes, question, yeah. I did, oh, sorry, yeah, you're right. I need to use chain rule. I started chain rule, but I didn't finish it, thank you. Yeah, I found the derivative, but then I didn't take the derivative of the inside. So that should be another 2, right? Derivative of the inside's 2. Because this was the outside here. Oops. This was the outside here. And then this was the inside here. Okay. So when I simplify this, actually the 2's will go cancel out. The 2's cancel out because 1/2 times 2 is just 1. So you're going to get that guy there. So let me go change this over here. Yeah, big difference. Thank you. Or else put it in a row. Okay. We know it's going to be a square root, right? We know it's going to be a square root because most of them, almost all of them have a square root. So we know it's going to be a square root. And then it's going to start 1. And the only ones that have plus in the middle are tangent and cotangent. So it's going to have a minus u squared. Okay, calculus is done. Now I just got to match it with one of my answers. Oh yeah, you're right. Yeah, sorry. So it would even easier than that, no fraction, right? So just square root 2x. So 1 over 2x. So the square root would be 1 minus, what is the square root of 2x? The square, this square, I should say the square of the square root is just 2x, right? Now, more than likely, that's not going to be an answer A, B, C, D because you have a fraction on top over a fraction. So how to simplify it? You have a fraction divided by this guy here, right? Keep, change, flip. Keep the first one. Change, flip this guy here. Then you would have the square root of 2x times the square root of 2x. If you were to multiply these guys, I could, I don't want to, you know, of course you don't want to, but you could, right? So if you needed to, if they wanted you to keep going with your answer, they both have square roots. So this is what I would do. I would put them underneath the same square root. And then do distributive property or distributive property. So you would have 2x minus 4x squared. And that's as far as you could go there. Okay, like I said, because you guys have, or these are most likely going to be multiple choice questions. So you're just trying to match it to whatever answer. This answer here is fine with me. But like I said, it's not up to me because I don't write the tests. So whatever the multiple choice part is. All right, okay, so we'll finish these tomorrow. There's a couple more, we just have a couple more problems. And then I'll assign you the assignment, which is which will start in class. Okay.